Good afternoon. My name is Olens Rukoto. I'm currently doing my teaching practicals with Stadio. So today we're gonna be doing what we call the physical sciences, grade 12. So we're only gonna be focusing on the chapter of mechanics. So mechanics is divided into different aspects for our physics paper one. And mechanics in exam contains around plus or minus 50 marks over. So today I'm going to be taking you through the work, energy, and power. So in the work, energy, and power, we're going to be focusing on the few aspects on how work is done in an object. So the work done is defined as the product of the magnitude of the force and the magnitude of the displacement between the force and the displacement. For example, when the work is done in an object, we're going to be having the mass and the force of gravity. So we're still saying that the work done in an object is equivalent to the mass times the force of gravity. And then here we have the work. The work done in an object is measured in joules, and then the mass is measured in kilograms, and then the force of gravity is measured in meters per second. And the force of gravity is constant value of 9,8 meters per second. So every time when we are asked to calculate the work done, or we need to calculate the force. So the force of gravity that we have to use is 9,8, not 9,81. So only when you go to tertiary, that's why they are going to use 9,81. But now you are still in high school, you are only using 9,8. So we also have this case here whereby the work is done in an inclined angle. What do we mean when the work is done in an inclined angle? For example, let's say we have, for example, we have a box, the crate of a box of a 10 kg in an inclined angle, and then this is the ground, and someone is pushing a box in here. So what is happening on this scenario? The work done that is going to be done in here is going to be displayed in this formula. We're going to have the work done is equivalent to the force times displacement and times what? The cos theta. So the theta is going to be an angle that is going to be acting on that horizontal plane in there. So the box here is placed in the inclined positions. That's why we now have what? The angle. So the W represents the work done, and then this symbol represents the delta x, represent the displacement, and then the theta represent the angle between the direction of a force and the direction of the motion. And then the cos, that's what we're talking about, is given by the friction of the force that is parallel to the motion. Thank you. Continuing with our lesson. So, for example, we have a block of 20 kg that is pushed along the horizontal surface. So on this scenario, if we need to represent or present first the free body diagram of this case. So a block of 20 kg that is pushed along in the horizontal surface. So first, before we calculate this question, we need to calculate what we call the weight done. So before we calculate the weight done here, we need to make sure that we analyze the question. We analyze the question. After analyzing the question, we draw what we call the free body diagram. So on the free body diagram, we're going to write all the forces that are acting on the object. Which object are we talking about? This is the object that we are talking about here. So on this scenario, this is going to be the box of 20 kg on the horizontal surface that is being pushed along what? Along the horizontal surface. So here we're going to be having what we call the force of gravity, and then here we're going to be having what we call the applied force, and then here we're going to be having what we call the normal force, and here we're going to be having our frictional force. So here, if we need to calculate the work done on this scenario, this is how we're going to explain that we have the frictional force that is opposing the motion of the object. We have the normal force, the force of gravity, and we also have what we call the applied force in here. So what is going to happen here? We need to calculate what the work done. So we are going to calculate the work done in an object. So the work done in an object is going to be calculated by this formula, whereby we're going to have what? Our mass times what? Gravity. What is mass times gravity? Is the one that we are given here from that diagram. So our work done is going to be equivalent to the mass times what? The force of gravity. So here we're going to say 20 kg and then multiply by what? 9,8. And then by doing that, our answer, you're going to be punching there in your calculators. Post. I'm going to post. So, okay, our answer here is going to be 196 joules, since our work is calculated in joules. So here we're only focusing on the work done in the horizontal surface. So we are also going to do another example whereby we are going to calculate what we are doing our activities on the work done in an object. So I'm going to be showing you some activities that you're going to do. I think it's just 2 questions that you're going to do in just like 10 minutes or 5 minutes time. Thank you. So these are the activities that we are going to do in here. So number 1, they are saying that an object weighing the 20 newtons slides the 5 meter to the right at a constant speed on a frictionless surface. Is it the work done or not? So we need to think about it and then do our calculations. Where we are going to use the formula says the work done is equivalent to the force times distance times the cost of theta. So we're going to use that formula to do our calculations in there. And then the second question as well, we are also given our force there measured in Newton. We are also given another force there on the rough surface of 50 Newton as well. Then we are going to do those calculations in there. So when you're done, you can kindly let me know, and then I will take it from there. Then I'll come and check what you did. Thank you. We're going to do our activity, which is